Hello, welcome to my Algebra 1 review series. This video covers Chapter 9, Section 2, titled Multiplying and Factoring. By the end of this video, you will have reviewed past lessons describing the methods of distributing a monomial, which describes multiplying a monomial and a trinomial. Additionally, you will have reviewed factoring a monomial from a polynomial, which includes finding the greatest common factor and factoring out a monomial. If you would like me to cover any of these topics in greater detail, please leave your request in the comment section below. Please subscribe to this channel if you find this video to be helpful. Thank you. Okay, Objective 1, Distributing a Monomial. In Chapter 1, you use the distributive property to multiply a number by a sum or a difference. Some examples are right here. So here we have 5 times the quantity a plus 3. 5 times the quantity a plus 3. And that equals 5a, 5 times a, right here, 5a. And then 5 times 3, 15. So 5a plus 15. How about x minus 2, the quantity, x minus 2 times 3? Well, we get x times 3, or 3x, that's right here. And we get minus 2 times 3, you get minus 6 right here. The quantity, negative 2 times 2y plus 7. So you get the negative 2 times 2y, and so that gets you a negative 4y. And you get the negative 2 times the 7 plus 7, and you get a negative 14. That's the distributive property at work. You can use the distributive property for multiplying powers with the same base when multiplying by a monomial. Okay? Good. Okay, example 1, multiplying a monomial by a trinomial. So here's the distributive property at work. Instead of like just doing a binomial times a monomial, we're going to do it times a trinomial. But it works exactly the same way. So in this case, we're starting off, it says simplify. Negative 4y squared, right here. Negative 4y squared. And that's times the quantity, 5y fourth to the fourth power, minus 3y squared, plus 2. So how does that work? Well, we take the minus 4y squared. Here's the term that we're multiplying by, right here. And we multiply by each term of the, so it's this times this times this, and then from down here, this over here times this. So we get minus 4y squared times 5y to the fourth. That's the first part. We get minus 4y squared times minus 3y squared. And then we also get minus 4y squared times 2. And when we multiply that out, what do we get? We see that we have negative 4y. Let me change colors. We get negative, right here, we get negative 4y squared times 5y to the fourth. When you multiply that out, you get negative 20, which is the 5 times 4, negative 20. You get the squared to the fourth, so it's 4 plus 2 when we're multiplying. Okay, so our exponents add. And then same thing here, we get the minus 4y squared times negative 3y squared. So you get negative 4 times negative 3 gives you 12. And then you get 2 plus 2 for the exponents right here, okay? And then finally we get negative 4y squared times 2. And that comes out to negative 4 times 2 is negative 8. And y squared times 1, if you wish, is y squared. So when we simplify all of this and simplify the exponents, x is what we're going to do here. We're going to get negative 20 y to the sixth. We're going to get positive 12y to the fourth because the 2 plus 2 is 4. And then we're going to finally get a negative 8y squared, negative 8y squared. Okay, example 1, check your understanding. We're going to do the same thing we just did in that last slide. We're going to multiply a monomial by a trinomial by a monomial. Excuse me, I'm getting tongue-tied here. We're going to multiply a trinomial by a monomial. And we're going to do that apparently 3 times in problem A, B, and C. It's up to you. Stop the video, pause it, try these out, see what you come up with. Come on back and we'll we'll take care of it again. We'll look at them. Okay, example 1. Now that you've had time to go over these, let's simplify each product. So what does it ask us to do? Multiply this trinomial, the first one right here, this trinomial right here, by this monomial. So what do we have? We have 4b times 5b squared. 4b times 5b squared is right here. 4b times 5b squared. Then 4b times b. 4b times b, and you see it there, 4b times b. And finally, you have 4b times 6. 4b times 6. Carry out the multiplication. What do we get? 4 times 5 is 20. B times b squared is b cubed. 4 times 1 is 4. B times b is b squared. Right here. And then finally, 4 times 6 is 24. B. There's our solution. 20b cubed plus 4b squared plus 24b. How about doing problem B? Negative 7h is being multiplied by the trinomial, or vice versa, however you want to look at it, of 3h squared minus 8h minus 1. Just like before, we're going to do negative 7h times 3h squared. Right here, negative 7h times 3h squared. Negative 7h times negative 8h. Negative 7h times negative 8h. And then finally, negative 7h times negative 1. Negative 7h times negative 1. When we do the individual multiplications here, negative 7 times 3 is negative 21. H times h squared is h cubed. Negative 7 times negative 8 is positive 56. Negative times a negative is positive. H times h is h squared. And then finally, negative 7 times negative 1 is a positive 7. And h is left, h times 1, I guess. So it's negative 21h plus 56h, negative 21h cubed plus 56h squared plus 7h. Finally, problem C, the same thing. 2x times the trinomial x squared minus 6x plus 5. And what do we get? We get 2x times x squared. We get it right here. 2x times x squared. 2x times negative 6x plus 2x times negative 6x. And finally, 2x times 5. 2x times 5. Carry out the multiplication in each. You get 2 times 1 is 2. X times x squared is x cubed. 2x cubed. Next, plus 2x times negative, or 2 times negative 6 is negative 12. X times x is x squared. And then finally, 2 times 5 is 10. And x was left by itself, or x times 1 if you'd like. So the answer is 2x cubed minus 12x squared plus 10x. Objective 2, factoring a monomial from a polynomial. Factoring a polynomial reverses the multiplication process. To factor a monomial from a polynomial, first find the greatest common factor, the GCF, of all of its terms, or of each of its terms, however you like to say that. Okay, in example 2, finding the greatest common factor. So we need to find the greatest common factor so that we can factor out that common factor from the trinomial or binomial or from whatever. And we'll show you how that's going to happen. So first, we're going to list the factors of each term, identify the factors common, and then identify the factors common to all the terms. So what does that mean? So we're going to start with the 4x cubed right here, 4x cubed. So what are the prime factors of 4? Well, the prime factors of 4 are 2 and 2. You can divide a 2 into a 4 and you get a 2 and remaining, and then you could 2 into a 7 and you get a 1. So there are 2 2's as prime factors in a 4. And this will come back to you, I'm sure. And then in the x cubed, you have an x times an x times an x. 3 x's. Those are the factors. On the 12 is a 2 times a 2 times a 3. Because you divide 12 by 2 and you get, all right, what do you get? You get a 6. And then you divide the 6 by 2 and you get a 3. And those are the common factors. You have x squared. That means we have 2 x's to deal with. And then for the 8x, we have 2 times 2 times 2. Because 8 is 2 to the third power. 2 into 8 goes 2. We have a 4 remainder, goes in there 4 times. And then you have 2 into 4 goes 2 times. So 2, 2, 2, and 1x. So now what are the common factors? Well, what we have to do is look at each set of terms and find which terms are common to all 3, in this case, all 3. And whatever the quantity is of that, we take the one that's the lowest of all 3. Because you can't go into, so I'll show you here. So we have 2 2's in here. We have 3 2's in the bottom term, down here by the 8. Well, we can only use, in this case, there are 2 2's. 2 2's in the 4x, 2 2's in the 12, and 2 2's in the 8, at least. Well, that's the minimum number of 2's we have common to all of them. Or let's put it this way, the maximum number of 2's we have that are common to all 3 of them. So we have 2 2's, and we place them down here, 2 2's. That's part of creating the greatest common factor. Okay? Then, for the x's, for 3, how many 3's do we have? We have 1 3. The 8x doesn't have a 3, and the 4x cubed does not have a 3. So you can't use the 3. The 3 is not common to all 3 terms. And then when it gets to the x's, the 8x down here at the bottom has 1 single x. So the fact that 12x squared has 2 x's and 4x cubed has 3 x's, we can only use 1 from each of those terms because that's the greatest common factor amongst the 3 of them. You can't have 2 x's because this 8x doesn't have 2 x's in it. It only has 1 x. So you have to go with the greatest common factor. Okay? So that means we have 1x. So if you multiply this out, we're going to get 4x is the greatest common factor. 2 times 2 is 4, times x is 4x. Okay? Okay, example 2, we're doing check your understanding. So just like we did in the last slide, we have 3 problems here. We'd like you to break these terms into these 2 binomials and the 1 trinomial into the greatest common factors, right? We'd like to know what the greatest common factor is. So I'll give you some time. Go ahead and stop your video. When you get back, we'll give them a shot. Okay, now I'm going to assume you've taken your time. You've done it. We're going to find the greatest common factor of each of these terms. So starting with A, we have 5v to the 5th power plus 10v cubed. So the 5v to the 5th power, we have 1 5. There's 1 5 in here. There's nothing else. That's a prime factor, and there's only 1. And there are 5 v's. So we have v times v times v times v times v. Okay? In the 10v cubed, we have a 2 and a 5. 2 goes into 10 5 times, and then 5 goes into itself 1 time. So those are both prime numbers. And we have v cubed, so we have v times v times v. So when we look at it, we have a 5 in both of these terms. We do not have a 2, so we can use the 5. Okay? And then with the v terms, we have 3 v's in the 10v cubed, and we have 5 v's in the 5v fifth to the 5th. Well, the highest we can go is 3 v's because it has to be common. The greatest factor common to both, or common to all. Well, that's 3 v's. So 5 times 3 v's happens to be 5v cubed. Let's try B. So we have 3t squared minus 18. So t3 squared is 3. There's a 3 in here, right? There's a 3. And 2 t's, 3 times t times t. Okay, then we go to the 18. There's no t at all, so guess what? We're not going to have a t in the greatest common factor. 18 breaks into a 2. 2 into 18 is 9. And then 2 doesn't go into 9, but 3 does. 3 goes into 9 3 times. 3 goes into itself 1 time. So the prime factors are 2, 3, and 3. So what's common to both of these terms is the single 1, 3, both of them have at least 1 3. Okay, so the greatest common factor here is 3. Let's go down to this trinomial. 4b cubed. 4b cubed gives us a 2 times a 2, because 2 goes into 4 2 times, 2 goes into itself 1 time. So a 2 and a 2 are the two prime factors. The b's, there are 3 b's. Well, we just break it into b times b times b. 2b squared. Well, 2 is a prime all by itself, so that's there. And then we have b squared, so it's b times b. And finally, we have 6b. 6 is not a prime number. It is a prime. 2 goes into 6 3 times, and 3 goes into 6 once. 2 and 3 are prime factors, so we have a 2 and a 3 and 1 singular b. So the GCF here is each of these terms have at least 1 2. They don't have 3's. There's only 2's and 3's, and the rest of them don't have any 3's. So it's a 2, and common to all of them is this 1b, because the least number of b's of the 3 terms is right here in 6b. So a b and a b and a b is 1 single b. So the solution here is 2b is the greatest common factor. Okay, example 3, factoring out a monomial. So it says, to factor a polynomial completely, you must factor until there are no common factors other than 1. That means that factoring down to the primes is what they're talking about here. And when we're going to factor this out, it's just like the distributive property in reverse. And that's what was said earlier in this section, that it's like multiplication in reverse, because now we're taking our terms from our trinomial and we're factoring out a piece of information. What we're going to factor out is the greatest common factor. Okay, so let's take a look and see what happens here. So we're going to start with step 1, which says find the GCF of these 3 terms. Okay, and what is that? So the first term is 3x cubed. So what is the greatest common factor of 3x cubed? Well, 3x cubed breaks into a 3. 3 times, and then it's 3 times 1 is 3. It's a prime. 3 is a prime. And 3 x's. 1, 2, 3. So far, so good. Now we go to the 12x squared. 12 breaks down into a 2 goes into 12 6 times. 2 goes into a 6 3 times. So we have it 2 times 2 times 3. And then x squared, we have 2 x's. Okay? And for the 15x, we have no 2's going to 15, but a 3 does. A 3 goes in 5 times, and 5 goes in 1 time. So there it is. 3 and the 5 are the primes of 15. And then there's 1 single x. So the GCF of this trinomial here, the greatest common factor, a factor that we can pull out of each one of these terms, okay, is there's a 3 in each of them, so it's a 3, and there's at least 1 x in each of them. This one has 1 x, so it's 1 x. That's it. There are no 2's common, because there's no 2 up here, and there's no 5's common, because there's only 5 in one and a 2 in the other one. So 3x. Here's our greatest common factor. So now what is step 2? It says factor out the GCF. Well, how do we do that? So let's start with the 3x cubed. And 3x cubed is, we're going to write the GCF, 3x, and then we're going to bring down these parentheses here, and I'll say, what times 3x gives us 3x cubed? Well, 3x times x squared gives us 3x cubed. How about this one here, 12x squared? So we're going to write down 3x in parentheses. What times 3x gives us 12 minus 12x squared? So to get the minus 12, we have to put a minus 4 here. 3 times minus 4. And x squared, we have an x. We need one more x. So it ends up being 3x times minus 4x. Negative 4x. And then finally, we have the 3x, the GCF that we calculated. Okay. And what times the 3x will give us 15x? Well, 3 times 5 gives us a 15x. So now the solution here is factored out is our greatest common factor times the trinomial. And the trinomial is x squared minus 4x plus 5. That's our factored, greatest common factor factored out of our trinomial. And if you multiply it back, you get it, right? 3x times x squared is 3x cubed. 3x times minus 4x is minus 12x squared. And 3x times 5 is 15x. Okay? So it's the same when it comes back. Okay, here we are with the example 3. Check your understanding. So it says use the GCF to factor each polynomial. So we have two binomials, and problem C is a trinomial. And what they're asking us to do is to factor it. So what you're going to, each problem is 2 steps. You're going to do step 1 to find the greatest common factor. And then you're going to use step 2 to factor that out of your binomial or your trinomial to get your factors factored out so that you can write your factored trinomial or binomial times your monomial, like we just did in the previous slide. So you go ahead and take your time, do it, stop the video, and when you come back, we'll continue on. We'll try them together. Okay, there's a lot of mathematics going to go on here, but it's pretty straightforward. Just take your time. Okay, now that you've returned, let's look at these 3 different problems. So it says use the greatest common factor to factor each polynomial. Well, our first binomial is 8x squared minus 12x. So let's look at the first term, 8x squared. That breaks into, well, 8 we know is 2 cubed, 2 times 2 times 2. Those are all prime factors. So there's our 3 2's from the 8, right here, 3 2's. And we have an x squared, which means 2 x's. And the 12x, we have 1x from the 12x. And the 12 gives us 2 times 2 times 3, all primes. 2 goes into 12 6 times, 2 goes into 6 3 times, 3 goes into itself 1 time. That's it. 2 times 2 times 3. The greatest common factor here is going to be, well, there are, 2 2's common to both. There's no 3 common to both. And there's 1x common to both. So 4x is the GCF. But so what they want us to do here now is to solve it and do this factoring. Let's pull out this term, this greatest common factor, and we'll end up with something that looks in the form of what, right? The distributive property. So we're going to take 8x squared minus 12x, and we're going to pull out a 4x. So we're going to start, that's our greatest common factor, and we determined that it's in both of these terms. So we know it's in there because we factored it out. So what is it? What is it times 4x that you can multiply and get 8x squared? So you could take in 4x and multiply by 2x and get 8x squared. So 4 times 2 is 8. X times x is 8 squared. The next term, 4 times what gives you negative 12x? 4 times negative 3 gives you negative 12. And 4 times 1, if you will, is x times whatever is x. X times 1 is x. So now we can factor out the 4x from these terms. And we have 4x times the quantity, 2x, right here, the 2x, minus, there's the negative 3 for the negative 12, minus 3. So 4x times the quantity, 2x minus 3, is the factored polynomial, factored into distributive property form. Let's look at B, the next binomial. 5d cubed plus 10d. Well, the 5d cubed can be broken into a 5. 5 is a prime number. And there are 3 d's. 1, 2, 3. Then 10 can be broken into what? We start with the 2's. 2 goes into 10 5 times. So we got the 2. 2 goes into 5? Nope, it doesn't. But 5 is a prime number. So 5 times 1 is 5 into whatever, right? You can't do anything with it. It is prime. Both primes. So 2 and 5. And then there's one singular d. So what's common to both of these terms? We have a 5 that's common to both. No 2s. The 2s are not. And there's one d that's common to both. Okay? So when you do that, you have 5 times d, 5d. So now over here to factor this 5d out of the binomial, 5d cubed plus 10d, you get 5d times what gives you 5d cubed? Well, 5d times d squared will give you 5d cubed because d times d squared is d cubed. And now what times 5d will give you 10d? Well, 5 times 2 is 10. d times 1, if you will, is d. So now we have 5d times d squared plus 5d times 2. So we can factor this 5d out. So we have 5d times the quantity d squared plus 2. That's in distributive property form. And finally, we have this trinomial to factor over here. 6m cubed minus 12m squared minus 24m. So the 6m cubed gives us a 2 and a 3. 2 goes into 6 3 times. 3 goes into itself once. And we have 3 m's from the m cubed. In the 12m squared, we're going to have a 2 goes into 12 6 times, and 2 goes into 6 3 times, and we have a 3 goes into itself 1 time. So add 2 m's. M squared is m times m. And then finally in the last one, we have 24m. So we know we're going to have 1m. And 24 breaks into 2 times 2 times 2 times 3. And we know it's 2 times 2 times 2 because it's 8 times 4. And 8 is 2 cubed. Or you could do it the long way, thinking, well, you could say 2 goes into 24 12 times, 2 goes into 12 6 times, 2 goes into 6 3 times, and a 3 remaining times m. So the greatest common factor is there is a 2 common to both. There's one singular 2 common to both, and there is a 3 here, a 3 here, one singular 3 common to all of them. So 2 times 3 is 6, and then there's one common m. There's 3 m's here, 2 m's here, but 1 m here, so the highest we have is m that's common to all of them, 6m. So now let's factor out from 6m cubed minus 12m squared minus 24m. Let's factor out a 6m. So 6m times what will give us 6m cubed? Well, 6m times m squared will give us, because the m times m squared is m cubed. Okay, how about this one? 6m times what gives us 12m squared, minus 12m squared? Well, 6 times negative 2 gives you negative 12. And m times m gives you m squared. So it's 6m times minus 2m. And then finally, what do we multiply 6m by to get negative 24m? Well, we multiplied 6 times negative 4 to get negative 24. And m times 1, if you will, is m. So now we can factor this out using the distributive property. We can take out the 6m out of each term, and then we get the quantity 6m times m squared minus 2m and minus 4. There it is.